All right, so now the cool thing about having this discriminant is we can use it and just, we don't have to use the whole formula. We just have to use that to find how many solutions we have in a quadratic equation. So for number 4, for example, and these are the ones we had earlier, but once you identify A, B, and C, right, like we did before, A equals 1, B equals -3, C equals -5. Now I can just plug them into the discriminant, which is B squared minus 4AC, right? Just what's underneath. And I can plug in the B, the A, and the C. Okay, and then just get that value. Remember, this came out to 29. Okay, and so since that's positive, right, since the discriminant is greater than 0, right, that means that we're going to have 2 real solutions. Okay, and then here it's asking us, like, what does that tell us about the graph, right? So remember, if we have a quadratic equation set to 0, basically we're setting y equal to 0, right? The output equal to 0, and where y equals 0 is on the x-axis. And so when we have 2 real solutions, that means our graph is going to cross twice, right? So basically we're going to have some parabola and it's going to cross twice, right? It's either going to look like this and cross twice, or it might look like this, right, and cross twice. And when I say, cross twice, as 2 x-intercepts, right? Okay. So let me add that in here. So it has 2 real solutions, or in other words, 2 x-intercepts. Okay. I'll write the word out. All right. So for number 5, I'm going to get one side equal to 0 like we did before. All right, and once we do that, we can identify A, B, and C. So A is 1, B is -3, C is 9. We can plug them into the discriminant. So B squared minus 4AC. So -3 is B, A is 1, C is 9. And so we get 9 minus 36. So that comes out to -27. Keyword there being negative, right? So -27, the discriminant is less than 0. So that means we're going to have no real solution. Oops, spelled solution wrong. All right, which means, we have 2 complex solutions, right? Okay. So, but as far as on the graph, what that means is it's not going to cross, right? So basically, we're going to have a graph where either the parabola is above the x-axis facing up, or it's below the x-axis facing down, right? So it's not going to cross the x-axis. All right. And so I'm going to put on there no x-intercept. Okay. All right, and we'll do the same thing for number 6. So A is 4, B is -12, C is 9. So we can plug them in. B squared minus 4AC. -12 for B, 4 for A, and +9 for C. And remember, this one came out to 0, right? 144 minus 144. So 0 equals 0, right? So whenever our discriminant equals 0, that means we're just going to have one real solution. Okay, and what that means is it'll cross the graph once, right? So what does that look like when a parabola crosses the graph one time? And you probably guessed it. It's basically going to be perched, right, on the x-axis like that. So just the vertex is going to be touching, right? So it could be perched facing up, or it could be hanging down from the x-axis, right, facing down there. So only the vertex will touch when the discriminant equals 0. So we basically just went through the exercise to allow us to fill in this table here. So now we know the number of real solutions, right? If the discriminant is positive, we have 2 real solutions. If it's negative, we have no real solution. And if it's 0, we have 1, right? And so as far as the number of x-intercepts, it matches up, right? The solutions are the same, or the number of solutions are the same as the number of x-intercepts on a graph. So 2 for positive discriminant, 0 for negative, no real solution, and 1 x-intercept when you have a positive, okay? So let's just match these up down here. So 1 solution here, this is when we have a 0 discriminant, right? Okay, 2 solutions is when we have positive discriminant, and no solution when we have a negative discriminant. All right, so there we go. Now, one other thing I want to point out, the discriminant also tells you if an equation, if a quadratic equation is factorable too. So, because if you think back to a square root in some of the problems that we did earlier, let's go back to, so remember, this is what's underneath the square root. So if what's underneath the square root is a perfect square, that's when you'll end up with a rational number, right? And those are the ones that can be factored for the most part. So if you end up with a number that's not a perfect square, like number 4 we saw here, right? If you end up with root 29, you're not going to be able to factor that, right? Because there's not going to be any real numbers, or any rational numbers you can multiply to get, 5, negative 5 here that you could subtract to get negative 3. So even though we had 2 real solutions, this wasn't a factorable problem. Okay, so that's another application of the discriminant, is if it's a perfect square, then you have a quadratic equation that can be factored. If it doesn't come out to a perfect square, then it cannot be factored. So it's a kind of way to check to see, hey, am I wasting my time trying to factor this or not? This can help you to determine that.